Okay, good morning everyone. We will start the SolidWorks session. So last time we looked at some advanced math concepts. Today I'm going to look at these math concepts plus the mechanical mating. So we are going to discuss these applications. So first we will look at this distance mate and angle mates. Part mate last week I did it. If you have any questions, we will repeat it again. So what is meant by distance mate and angle mates? Already we have discussed some concepts about distance and angle, but here we can give a limit. So this may be important when you do work. So you can have a range in the distance. So we will do a small application and see how it works. So I'm going to open our part files. So we can take the same usual body wise jaw example and show you how to apply the distance mates. So I will take this body. Then I will use the jaws. Uh, so I am getting a small error here. Wait. Okay, so we will assemble these two. We know the methods of assembly. I think I am in the wrong mode. That's why I am getting these errors. First, we have to start the assembly mode. Now it's automatically mated by some of the mates here. Coincident mate is applied. Coincidence here, parallel here. So since this is parallel, I can slide, but it's penetrating through the vice body. So if I try to apply a mate called, say I will remove this parallel condition. Now it's still sliding like this. So I need this one and this one, otherwise it will come out of the body. So if I try to apply a mate, so we can go to these areas and see whether we can use this tool. So there's a tool called distance mate. So if I just enable this and try to select this face and this face, you can see it's now coincide with each other. So I can adjust the values now. So this is the default distance. So if I just give 10 millimeters, by default it's adjusted as 10 millimeters, and here I can give a maximum and a minimum value. Minimum value may be 0 and maximum can be you can up to here. So you can get the distance from here to here and give it. So for the x, since I haven't calculated, I just give 50 millimeters. Now what happens here is when I press OK, this will not penetrate now. This is the minimum length and the maximum is 50. So from here to here it's 50 in length. So if I just measure it from this line to this line, from here to here it's 50. So it will not go beyond 50. So if you just try to measure from here to here, it's 202. So actually we have to measure it, get this distance also. 202, this value will be 32, then 202 minus 32 is 107. So if I give that value, say limit as 170, it stop it at exactly in the other end. Say if I just give 170 as the maximum, okay, okay, minimum is 0, maximum is 107. So you can see it will not go beyond these limits, it will automatically stop there. So I hope you understood the concept. You can try it and see. So what we did was simply we went to mates here. Don't use this distance tool. This is a fixed value. So standard mates also has this distance, but I'm not using that one. I'm using advanced mates, and you have this distance tool. So you need to just select the two parallel faces in this case and give a default value is this is the default value, and this is the maximum value, in this case 170 in my application, and minimum value you can adjust. Say if I give 10, it will not go and hit there, it will stop somewhere here. So okay, okay, now when I do it now, this is 10 107, 10 107. You can try it and see. Any questions, please let me know. Any questions about this? So this is like a limit switch. So if you don't have questions, I will move on to the next name. So I will go move on to the next one if you don't have questions. So I will look at the angle mate. How can I have a limit for the angles? Now we will get our usual example, which was in chapter 12. I'm going to get that usual example which was in chapter 12. This one, 1220. So I will get this base and the upper links and show you how to apply an angle link. So we can quickly assemble this thing. So we already know how to do these things. Then we have upper link, those parts. Now I can use the advanced methods or just normal methods. So if you use advanced methods, you can use smart ways or you can drag and drop. So a lot of ways are available. So I just use a smart way. Okay. Now this is rotate. So have something like this in your computer. Then we will apply a angle limit for this. So I have just done some basic concentric coincidence. So here this is also rotating. We have discussed this. So relative to this base, this pin is also rotating. So since this is rotating, this will not move. So you have to use this handle and rotate the top part separately. So we have discussed these things in the previous classes. Now when you try to apply an angle mate, uh, it's under advanced again. Under advanced you will find this angle tool. So you need to turn this on. All these set of techniques you have to turn this technique on. But in the standard methods you no need to come and click this, software will automatically pick it. But in the advanced mates you have to think and select the correct method. So angle mates, just need to select two references. Say this may be my first reference, this may be the second reference. So sorry, this is the first one. Uh, so this is 0. So you can see it works. So don't need to give this one. So you can have a default value, say 20. Then maximum maybe 90. Minimum maybe 0. So now if I animate it, if I just drag it from the handle, this is maximum 90, minimum 0 degrees. So you can see this is 0, this is 90 degrees. So this way I can have a limit for this motion. Or else you can apply a motion study and stop the motor in the correct angles. So that can be also done. So you can have a motor placed here and motor can be stopped. Otherwise, if the motor is continuously rotating, since there's an angle limit, automatically it will stop. There are two ways. You can have a continuous rotation model and stop the model from the motors. Otherwise, you have it in the model itself, the limits. So we can apply a rotary motor and see how it works. Make sure you apply to the link correctly and direction. 100 RPM. Okay. Now when I do a animation, it won't go until this. Say we do it slowly. So it will reach 90 and it will come back again. So you can see how it works. Otherwise, you remove this time frame, and you can reduce the time like this. OS, you can. I haven't discussed these things in detail. Uh, you can go to motor here and right click on this and have a key. So you can OS, you can off the motor from here. So time frame is up to 5 seconds, but the motor is stops here. So you can right click and do those things, turn the motor on. and right click and get so somewhere here we can have another key. Right click and place a key. So these keys will show you the values at the moment. So there are a lot of ways of doing these things. We will discuss these things in a little bit later. So we can do a lot of fine adjustments. So that's a topic to be discussed later. So I hope you understood the concept. Any questions about this? So I applied a normal limit, this angle limits. Just clear the references and give the default values and the maximum minimum. Then I showed you how to apply a motor and how it works, and we can right click on this time bar and have keys or turn off the motors. Lot of things can be done. So I can turn off the motor from here and right click again and take it on. So it will go until 5 seconds, and we can have a key here and edit the key properties. So there are lot of methods available. So we will discuss them later in an animation lecture. Uh, any questions about these basic two methods? So I have discussed angles and distance. So in linear coupling, what we are going to do is we'll use these simple files and show you how it works. Now, if I just open this assembly, uh, now I have done some simple mates. You have a part like part 1 is there, part 1 is this slot kind of shape, this U shape, then we have another U shape, then this is the sliding part. So I have applied some mates called coincident, coincident, here coincident, coincident, and here linear, linear couple. So what happens when I try to practice? You can see how it works. So when I take it back to the default location, so all are coming back to the zeroth location. So you can see how the movements happen. So you can have a ratio between this movement and this movement. So I think here it's 1-to-1 movements. When I travel one unit here, this can be travel 2 units, or this can travel the other side also. So these kind of sliding mechanism you may have seen in real in day-to-day life. So how can I get something like this in the SolidWorks software? So if I just delete or suppress this what this mechanism here made, it's just a normal sliding happens. So this is normally sliding, and this is also independently sliding. So you have to have a part, say, 3 parts like this. So if you don't have these 3 parts, just try to draw it quickly. So what I do 3 parts like a L shape here also with a slot here and another part. So if you don't have parts, I will give 1 or 2 minutes. Just quickly draw it, and we can apply this animation and see. So our target is to have something like freely sliding 3 parts like this. So if I just start from the beginning and start from the beginning, I will keep this one and start a new file. Okay, I'll start from the beginning. Uh, we have to get the base. If you don't have, just draw these things. Sometimes you may have these things. Linear coupler, part 1 is the base, something like this. These are the simplest examples to explain these concepts. That's why I have drawn these kind of things. This is the second part. This is the third part. So I am going to assemble these now with simple mechanisms. So you can use the normal mates or advanced mates or whatever the easy things for you. So I will just use this one, this one. Okay. Then this made with the bottom place here. Okay. Now it's done. Then what we can do is we have to get it to the origin, so the starting location. So to get this into a starting location here is somewhat difficult. By using your naked eyes you can't do this, so we will ask the software to do that. We can ask a temporary mate. So I haven't discussed this theory. There's a tool here called, at the bottom of the list you will find show use for positioning only. So there's a tool called positioning only. Otherwise, if you just apply a permanent mate here, this is permanent, so this will be fixed now. This, there will be no minus sign, so you will have problems of animating. So now this is fixed, so you have applied 3 mates. So we can't do that way, so we have to ask the software to have it temporarily. That is, there's a tool called positioning only for positions. Positioning we are going to use this. Now what happens is we can get it out. So I'll do it again. Suppose you have this kind of a thing. You apply a positioning only mate for this part as well as this. Now what happens? Mate happen, but it won't say you this is my fix, and you will not find that mate here. That means you can animate it easy. So when you try to do animation, these kind of tools are important. You have to take everything to the default locations or the origins before you apply the animations motors. So this tool, remember this tool is important to get it to the neutral position. So we can select this one and this one, and neutral position is now achieved. You will find there is no coincidence happens. Then we can do normal mates to this part. Now we have to get this rod up to here. So we apply a positioning only mate for these two surfaces. Now it's a temporary mate. You will not find it. Okay. Okay. Sorry, this was also temporary. So I do it again. Make sure this is not tick. So I will do it again. This one done. Then this face, done. So make sure you exit from here. Otherwise, all the things will be positioned. So here I have made a mistake. Okay. Now you apply a normal positioning mate to this part as well as this. Now it's a temporary one. You will not find anything. So I have applied 4 and 2 positioning mates. I hope you understood what I am doing. Then we will try to apply a linear coupling. So in the linear coupling, you don't find any rotational couplings at the moment in SolidWorks, only linear. So you have to give these inputs, mate selections, entity to mate. Then say we have to have a relative motion between this one and this one, this one and this one. So if you just look at the file I did earlier, this is the completed example. This completed example, if you look at it, you have to give a relative motion between this one, and this one and this one. So if I just expand this and show you how I have done it. So you need to only give this input and this input. So phase 1 and phase 2. So these two inputs should phases should be given, and here we have to give the ratio between the movements. Now what is the meaning of this one is, when one part is moving 1 millimeter, other part will be moving 2 millimeters. So if you apply a reverse operation, when one is going forward, other one will go backward. So this is the mechanism I have to give in this example. So we'll go to mates here and select advanced linear coupling, and we'll find this set of inputs, and we have to give first, no need to give this one because this is free. So you have to give this phase, and automatically software will jump to the third box and this phase. Now I have given it, my ratios are 1 to 1. Say I have to have 1 to 2 or something. So you can see how the colors matches. This light color, when light color phase move 1 millimeter, this dark purple color will move another 1 millimeter. So else you can have 2, or else 3 millimeters. So this dark one will move 3 millimeters, or else reverse one. So when you press OK, set had been applied. Now when you move 1 millimeter, this is moving 3 millimeters. So if you just evaluate these distances and see, this is 27.74, this is around 77. So it's 3 times 77.22. So it's 3 times than this. So I hope you understood. Now when you take this back to or normal position, it's reversing. So you can take this way also, or else you can drag it from here also. So if you try to reverse this operation by reversing, this dark purple color will reverse. So you can see how it reverses. So this can be also done. So without having physical linkages, we can animate it in the software and see. So if I want to take them everything, now I have reversed it, so I have a problem. So I will just suppress this and take them to the default location. Now when you try to take the default location by manually, it cannot be done. So you can use this mate and use the positioning only tool and take it to the default locations this way. This is a positioning of only tool, positioning only, take it to the default locations. Okay, okay. Now we can unsuppress this and animate it again. You can see how it goes back. So when you take it to the default location, this is the situation. You can try it and see. Any questions, let me know. I hope you are following what I'm saying. So the important settings are selecting this face and this face and giving a ratio. It can be 1 to 1 also. So I hope you are okay with this. So these kind of things we haven't asked in the in our assignment also still. So be ready with some questions we haven't asked actually. So this was not tested in any of our exams still. So we had around 5 4 uh, SolidWorks animation exams. So last time we had a gear mate robotic arm. So this time we may give something like this. So better ready with every technique I am teaching you. So any questions before we move on to the mechanical mates? So we have done standards and advanced mates. Next week we don't have a class. Week after that we will continue. So I have around another 4 sessions. So we have to discuss some of the pattern tools here. So there are some more things available we didn't discuss still. So before that we have to complete all these mechanical tools and other advanced tools. Any questions about this before we go on to the mechanical tools today? So if you don't have questions, I will start with the cam mate. So we will start with an example. So this is about cam mate. So you may have seen these things in in vehicles. So this will rotate and this cam follow will follow the cam mate motions. Sorry, cam motions. Then it will connected to the rockers and everything in the engine. So engine pistons will, injectors will work. So those kind of mechanisms are available inside the engines. So this is a simple motion I am going to explain now. So I will open these files and show you how to animate a cam mate. Actually, we have given a question based on this. We gave a question to animate a rocker arm in the engine. So we ask you to draw these parts and the rocker also. So at the end of the day, we can put a motor and animate it and see whether it's nicely opening or not, the valves. So we will start this example. So I have a folder called 1366. So we will take the cam and the base and the follow. Already this is assembled in my computer, but we will start from the beginning. So we have to have the base first. Then we will take followers and we have to take the cam. So you assemble this using any of the methods you know. So I will just use a simple method. Now I should have a slide in follower like this. So don't worry about the limits here. It will not go beyond this anyway, because after assembling it won't go. Then this is done. Then we can assemble the main cam, and this should come here and hit here. Now these heights are same. Okay, okay. Now this is the thing we need. So you have to have sliding follower and a rotating cam. So next we have to apply the mate. So I have something like this in your computer. We will apply the cam mates and show you how it works. So when this rotates, uh, this will go up and down. Then this will connect to a rocker, and rocker will operate. Rocker will also connect to a valve here, and valves will be automatically go up and down, and it will open the valves and close the valves for the cylinders. So I hope you can do this simple motion, simple assembly. Any questions about the assembly, let me know. I will give you 1 or 2 minutes to assemble this. So if you have assembled this, we will move on to the uh, animation. So I will look at this mechanical mate called cam. So this is not a difficult thing, but when you do a design by yourself, you have to do calculations such that this cam will always touch this followers this side of the face. So when the cam rotates, always this will the touch somewhere in this face. So you have to do calculations for these things. So cam path is and the follower. So the path is this. So when you select this, automatically the chain will be selected. So when you do a design, you have to make sure these are tangent. These lines are tangent, and all these are tangent to each other. Otherwise, it will not select the entire loop automatically. So those are the challenges we have when we do our own designs. So cam follower is also selected, and automatically it comes and touch here. So when you animate it now, you can see everything is touch. Every time it is touching with each other. So cam is always touching the cam follower. So I hope you understood this. So now when I press OK, it will give some warning, but don't worry. OK. Now this is the situation. So I can apply a more time, animate this if you like. We'll apply a motor here to the cam. Make sure you select the edge of the cam, not the edge of the uh, not the cylindrical part here. So you have to select the edge of the cam. Give a RPM, okay, then animate. So it depends on your computer processing power. So this is how it works. So you can do it and see. What I did was I applied a mate for cam mates, and I just selected the path. I don't need to select everywhere. You just select one position, and automatically it will take the whole chain. Then the cam follower this face. So if you have finished with this, you can, if you have these files, okay. Otherwise, just try to draw something like this. This is for slot mate. So last week I showed you a YouTube video based on slot mate and path mates. So if you don't have files in your machine, just try to draw a slot shape as well as a cylindrical shape like this. So I will show you how to move this along the slot. How to move this tab along the slot without applying any limit switches. So we can, without applying limits, we can just move it nicely. So next topic is slot mate. Better have some files like this. Okay, so we will start the slot 2. If I'm going fast, tell me. Anyway, you can look at this recorded video later, but better you learn then and there, then it will save your time. Uh, so we will show you how to apply the slot mate. So I take this base, simple design. So you can use the slot tool and do this design. So if you just look at the extrusion sketch, this can be done. Sorry, this can be done from slot tool available in the SolidWorks software. So I hope you can remember all this theory. Then we will get the tab. So now if I want this to be moved along the slot here without coming out, there are two ways. Either you can have limits, distance limits. So when you try to apply distance limits, you have to calculate these distances and give a minimum or maximum value. So that's going to be tough. So without that, we will just apply a slot mechanism. You need to just select the two mates. So you can select this in place or this one. Automatically it happens. Now the slot mechanism has been applied. You can have it free or center in the slot. Likewise, you can have it in different ways. Now after this one, I have to do a normal assembly also. Otherwise, this is out from the. This is already out from the. This is already out of the slot. So if you just try to press OK and try to animate, you can see this is not working correctly. So it's not working correct. So I will just delete this and do it again. Better you have this kind of a thing first. Okay. Then you go to mechanical mates, select the slot tool, select this one and this one. Okay, you can see how it works now. It will not go out of the slot. So I just selected. I first gave this coincident maze just to make sure it's coming out. Then I gave a slot mate. Simply I just selected this end face here and the face of this cylinder. So that's what I did. You can do it and see, and if you put it into center, it's like this. Center, it's not going to move, so it's not free now. So it's exactly at the center. So you can't move it when you have the center. So better you have it free here, then you can move it. Okay. uh, so I hope you are okay with this. I hope you can remember the last week video I showed you, YouTube video. So it couples both pathmate and slotmates. So we show it again. This one. So it couples both cam slot and pathmate. So you have everything together. So just go through this again. So I hope you are okay with this. Any questions up to this point?
So, sir,
Yes,
sir, in that video for the second slot, he used the path no, sir.
yes.
So rather than using a path, we can have the slot mate again onto those two at the bolt and the path.
Because that one he used the pathmate because it's not a straight slot. Uh, this mechanism will work for straight slots. What I taught now, this is working for straight ones only. So if you have a curve slot, you have to rely on the pathmate also. That's why in the video he
Uh-huh.
applied the slot and the path both. Uh, got it? So this is working for
Yes, sir.
straight
Yes.
slot.
Okay.
Okay.
Okay, sir. Thank you, sir.
We have some advanced things coming up. Gear mates, screws, hinge, rack and pinion. So uh, to start, are you okay with the previous this before we start this rack and pinion, screw mates, hinge mates? Uh, we will try to. I don't. I think you have the files with you at the moment. So if you don't have the files, I will quickly share it with an email. So we have this nut and bolt assembly. So if you don't have this one, I will quickly share it with you. Uh, so if I just open this nut and bolt, I'm going to discuss about the thread mechanism. So now the thread cutting, this is actual thread has been cut. So you can use the sweep tool and cut, or else now nowadays they have given the cut thread tool also in the SolidWorks. Now the idea here is when I rotate this, this should sorry this sorry this nut should go up and down. So you can see you can animate it and nicely see how it is given. You see whether we have animation. Yes, animation is there. So when you animate it, you can see how it works nicely. So this can be applied to our tutorials. I told that in the first tutorial we discussed in chapter 12 first tutorial we have, I ask you, no, don't animate this thread one. We'll discuss the thread mechanisms and do it. So we'll open the tutorial and show you. So in this first tutorial, when we rotate this handle, your this should go backward and forward. That is the idea. So you can apply a thread without drawing threads. You can do this. So no need to draw actual threads here to do this work. So you can assume there's a thread between this part and the rod here, and we can animate it. Now in this example also what they have done is that. So if you don't have a file, I will share it with you. So if you just look at the things we have done, the simple concentric mate has been applied. Then we have applied the screw bolt, screw thread mechanism, screw mechanisms. So in the screw mechanism, we need to just select this face of the bolt and face of the nut on. And here we can apply this conditions, distance per evolution, what is the distance. Likewise, some conditions, reverse mechanism. That's all. So it's a very simple thing. So if I just delete this, you can take this out. So this is a part of this file, so you can hide this if you don't like this. That can be quickly done, no problem with that. So that is not needed. So we have applied a concentric mate. Then we need to just go here and apply screw mates. This. So you need to just select the face like this here, and a face in the thread. That's all you have to do. So now when you press OK, okay, it should work. So you can see it's moving out inside, it's coming out. You can have this way. So better you put a motor and animate this, otherwise I have to turn a lot. So you can see it's coming close. So it's not a difficult tool. Only thing is you need to select the face here and the face of the thread here. Better you select a flat face like this, not an angle. So just if you don't have a, you can apply this into your tutorial question and see whether it's working. So that bench choice tutorial we did last few weeks ago, I think Mr. Sean has completed this tutorial for you. So when we rotate this one, this should go backward and forward. So we have to apply a screw between this one and this face. So this face and this face we can apply a screw mate and do it. So I will just try to apply it. Select this and this, and we can give uh, per distance per revolution, say 2 3 millimeters. Okay, now you can see how it works. So when you rotate this, it's nicely coming out. So I don't need to have actual threads. This way, the other way, it's going inside. So you can put a motor and animate this. I hope you understood the concept. So I will quickly apply a motor to this. is how it works. So nicely you can animate. Then uh, if you change the motor direction, you can see it's going the other. So we have to do a calculation. I hope you see. So it's still remembering the previous values. So this way we can do it. So I hope you understood the concept. So I just applied a small screw mate here. So between this one and this one, I think we don't have fixed mate. Only a concentric mate and a coincident mate. So this is free to rotate, and it will go backward and forward, assuming there's a thread here. So any questions about this? Let's try to apply this and see. I just gave two faces, this face and the inside face.
So if we had the threads made in this rod shaft, so we, so will it move without the screw mate?
How does it it didn't happen in this previous example also it didn't happen. So the nut and bolt example, even though we have the threads physical threads here, without this it won't animate. You have to apply. So if I just suppress it, it's just a slide. It won't work. It won't work in a systematic manner. Now when you give this one only, it will do some calculations and move it according to some values. Otherwise, it's just a free motion.
Okay, sir. Thank you.
So actually, we haven't asked questions from these things still. So be ready with any of the mechanisms for your assignment. My idea is to teach you all these things. Then when you go to the industry, there will be no problems with you. So when you get a project, you can nicely design and animate and show it to your seniors. So that's why we go through all these things. Otherwise, sometimes when you try to do a project, you will be struggling to animate the things. Uh, that's why we go one by one with each mechanism. Uh, if you don't have questions, we will move on to the next one. We have advanced things like gear mates, rack and pinion. Hinge is not a difficult one. I will just look at the hinge first, and we will, if time permits, I will look at gear mates and rack and pinion, and we have universal joint also. So we will start with the hinge mate. Actually, this hinge mate can be obtained from normal mates. Some of the things I am discussing here can be obtained from normal mates, but you have to do several mates. That's why they have introduced the direct tool. So if you look at the hinge here, we can get this mechanism by normal mates. But we have to do a lot of, say, at least three operations. But to reduce our time, we can use this inbuilt features like hinge tools. So this can be a hinge of a door. So if you try to do it normally, what we will do is we will just apply a normal mate like concentric. this can be done. Then we will do something like a coincident here, and and something like this. So I did what I concentric. I use the concentric limit and coincident, and you can apply angle limit here. What we have discussed earlier. So we have used that. We can use the traditional this. That's what I'm trying to show here. So you can use a traditional angle mate, give some limits. So we can select this face as well as this face and give a default value, say 10 degrees, and maximum value is 90 degrees, then the minimum is 0. Likewise, in a traditional way, we can do this. So I have to do 3 operations. Now this is 0, this is maximum 90. So this is the hinge mechanism. But without doing all these 3, we can do this one in one operation. That's why they have introduced a new tool called hinge. So I hope you understood. So we can use traditional ways as well as a shortcut. So I will delete all these things and use the directly available tool called hinge. This one. So in the hinge, what we do is when you start this tool, you'll see they are asking the same old things we have done. So they are asking the concentric selection. So earlier I did the concentric selection here. So I just selected these two earlier also, but they are now giving it in a one box, and coincident selections, same thing, they have actually compressed the things into one box, and angle limits also they are giving it in a single box. So you can select the faces and give a angle limit. Now here in this case they are measuring the angle in the other way. So if you just give, say, default value 60 degrees, they measure 60 from this side. So this is somewhat different from the old methods we discussed. So better be careful with this. So if you give 120, it's measuring 120 from here to here. So I gave this face and this face. So he's taking the big angle. So 120 degrees is the default value. Then maximum can be, say, this one, and 0 if I give this way. Your animation happens. This is maximum, this is minimum. So this is how the animation happens. So it's a single method, but actually it is the traditional method because it's all the three things I did earlier is available. So we gave concentric, we gave coincident, as well as we gave angle limits. Can do it and see any questions. Check. questions? Okay, so if you don't have questions, we will move on to the gear mates, but I will not complete the full gear mate mechanism today. I have to go give this menu to another lecturer. So until she comes, uh, I will start this one. But we will complete the gear tutorial gear mechanism next week fully. A week after that. So I will try to animate a simple gear mechanism by importing these shafts and the gears. But we will do it in detail in the next lecture. So for the time being, I will just start this. So we have already assembled files also. So we will start with the shaft and the gear. So last time I showed you how to assemble a conveyor belt. So better we have a shaft which is fixed to the screen, and we can have a gear imported. So the shaft is fixed and gear can be rotated around the shaft. Or else you can have these two together and rotate the shaft also. So I will just keep the shaft fixed and rotate only the gear. So we can apply a normal mate, and it's kind of, so last year tutorial based on the gears. So we ask you to draw the gears. You can draw the gears as you if you like, or else you can import from the libraries. So we gave both the methods. You can use both methods in the last year paper. So we gave the freedom to the students to do whatever they like. So next day I will show you how to import this from a library and customize your gear shape. For the time being, we will use the gear available here. Now I imported the gear. This gear is now really rotated. Now you have to get another gear and couple with this one. So if you just look at these measurements, this is not the 100% accurate way of doing this. I am just showing you another way. But for the exams, we are doing it in an advanced manner. So this is 155. So this diameter is 155. So other gear should be having the same distance from the center to this center. There should be 155. So radius can be double, then it will be 155. So if you do that way, you will not get a precise gear made, but you can get it uh, slightly okay mechanism. So I will just have another shaft. So this shaft should be away from the shaft 155. So the easiest way of having this is having a mate with the something like this. Take these two plates and apply a mate and have the gap 155. So this is without any tolerances. I'm giving exact value. Then we can have another. This is going up and down now, so you have to stop that. So we can use another plane like this, and this it. Now both are in poly. Then we can have we have to stop this motion, otherwise this is going here and there. We have to stop that motion also, otherwise this is going here and there. So if you stop it, take this as the parent, this as the child, and then just okay. Now I got a shaft exactly 155 away from this shaft center. This is fixed now. Then you can get a sorry, you can get another gear and do the same things I did earlier. Now this should rotate. Now this is not very accurate because these are actually overlapping. So when one is rotating, the other one nicely should move. So you have to have something like this in your computer. Then what we can do is can apply the gear mate. So I'm going to apply the gear mate. Next day also we look at it in a precise manner. So today I'm introducing the concept. So there's a tool called gears. You need to just select the uh, entities to mate. So you can select the edge of the gear, this circular edge. Make sure you select it not in the shaft, in the gear. So I'm selecting the shaft. So if the shaft is selected, you can hide the shaft and come. So if you are not sure whether this is not going to select correctly, just shaft, hide the shaft, and now the gear will be selected. This edge as well as this edge. So once you select these things, automatically the teeth will be calculated, and you can have a reverse operation. And if you press OK or try to animate, this is the situation. But if you reverse it, it will be in the same direction. But you can see there are problems in this mate. So this is the problem I'm having. So it's going through each other. There are interferences, but the animation works. But the interferences are there. So if you want, you can have a ratio, not 1 to 1 ratio. You can override this one and give a different ratio even. So it will be highlighted. Now this is not the real case. So in the computer, we can do whatever we like. We can have a virtual. This is a virtual environment. So I have a problem here. The problem is mechanism working, but these are interfering. So we can avoid those things. We will look at that later in next day class. We look at how to avoid these kind of problems. So hope you understood what I did today. So I just select the edges of the two gears and it worked. But problem is material is interfering with each other. So I hope you understood how I got these assemblies. So shaft is taken first, then a gear was assembled to the shaft, then another shaft taken, 155 away, and the gear was assembled to that shaft. And we applied gear mates between these two gears. But this is not the 100% accurate method. So next day, please have these toolboxes ready with your computer. So you need to have the toolboxes available. I hope everyone is having a full version software in your computer. So just go to libraries here and have these toolboxes ready for the next day. So we have to use these already available shapes. So you don't need to draw nut and bolt, you don't need to draw bearings. These are actually available in the market, so we don't try to design it again. So these things you should be there in your computer. So when you start these things, uh, these gears should be there. So we will discuss how to apply, how to get these gear mates for helical gears, and rack and pinion also we may discuss. So some of the things we will try to introduce. So these are actually not in our syllabus early days. We are trying to introduce new techniques. So better you have this in your computer, have the toolbox ready for the next day. So I can use these readily available shapes. We don't need to draw these things. That's the main point I want to tell. So these are available. So don't worry about drawing the things. So for in the exam, we give the freedom for you to either use these things or draw by yourself. So whatever the things you can use for the exam. So we will give you those all the steps needed for the exam. Any questions up to this point? So when we import this gear, now the gear is there. The problem here in our animation was we didn't talk about this module, pressure angles, or the other properties. That's why we had this interference. So actually, I hope you know about these terms at the moment. So these should be much. Excuse me. So when you do this animation, there were interferences because we didn't thought about these uh, modules, and uh, we didn't talk about this module and other things. So be ready with the libraries. I will talk to you next day. So I have to wind up for today. So thank you for participating.